Okay, so let's get started. Hi, everybody, and welcome. Thank you for joining our presentation. It's time to get your R&D building in order. Before we start the presentation, I'd like to introduce our speaker today. John Conway is the Chief Visioneer Officer at 2015 Visioneers and has 30 years in science and technology. He has contributed to numerous small and large molecule programs while at Merck, GSK, and AstraZeneca. While working for Acceleris, he contributed heavily to scientific software platforms like chemical and biological registration, experiment knowledge base, and Torpedo. And at Schrödinger, he worked on live design. Most recently, John was the head of R&D and CIT at MedImmune, a subsidiary of AstraZeneca, and chief commercial officer at Riffin before deciding to start his own consulting company, 2015 Visioneers. John is also on the scientific advisory board of Cyclica and Altus Labs, each of which are doing great things to improve the quality of life for all beings. Welcome, John, and thank you for presenting today. I'll turn the floor over to you now.
Great. Thank you very much. Thanks, everyone, for taking the time to come to this and listen to me talk. I'll answer any question you have. So today, we're just going to talk about a plethora of things, and there'll be some overlap. There'll be some repetition because I really want to kind of hit the point home. I've been talking about these things for years now, and I'm actually starting to see a lot of progress in the R&D space when it comes to scientific data and processes and driving the AI ML approaches to things. It's actually starting to come to fruition across the board. But we'll talk about culture and why it's really important, the systems in R&D and kind of how they overlap with like systems in a building. I'll try to use that as an analogy. Stick with me on that. It's refined, but it's got more work to go. And then recommendations throughout the talk. And then the key thing here is I'm trying to keep it simple and straightforward. The devil's in the details, as everyone knows. No matter what you do in life, the devil's in the details. So first off, I just want to say that discovery, research, and development is extremely difficult and challenging. If you look at today's pandemic and the rush to get a vaccine, actually the rush to treat, the rush to prevent, and ultimately the rush to cure is extremely complicated, and the promises of vaccine and treatment and all this, and we're seeing one after another kind of fall through. And that's because this is really hard, and it's a very difficult RNA target. So hopefully the great minds of the world will come together and get something done. But if you compare discovery, life science research on the left with all the flavors and ramifications that you actually have to go through to get a drug to market, and you compare that to blueprints in a building, a skyscraper in Manhattan or some big city around the world, they're both very complex systems. The only advantage, and some may say it's a disadvantage, that a complex building system might have is that you can physically see things. You can draw them out and you know where they're going to sit. You can describe them mathematically pretty succinctly. And that's a big advantage because a lot of the work we do in life science and materials sciences, we can't actually see. It's all based on theorems, rules, previous experiences, etc. So the world is still very unknown in the science world, especially in biology. It's very unknown. We don't know anything in biology today. So some key observations over the years. That is leading to this better environment is that data and processes aren't findable, accessible, interoperable, and reusable. It's a very simple acronym, but it concisely describes some of the data and process environments that we deal with in R&D. And part of that is that the valuable asset that they are has been lost. Back in the 90s, when things were, let's just say, a little simpler, but not as advanced, at least when I was working at Merck, we valued data very highly. It was the asset was considered an asset, and we guarded it. But somewhere after 2000, it started to fall apart. The scientific community, and it's been shown in the academic community significantly, but it's permeated and made its way into industrialized science, is the replication crisis that we also have. And I did a webinar on this back in January. We have a difficult time reproducing things and replicating things in the lab. And it all comes down to human behavior and the inability to value the assets and many times just do the right thing. Many of these companies haven't adopted a scientific data and process strategy. It's no different than anything else in life. When you commit to something, the best thing to do is write down what you're committing to, write down what your sacrifices are going to be, et cetera, and you will 9 times out of 10 achieve that goal. It's missing in many companies, and the latest survey I gave a couple of weeks ago, it's still only at, I would say, somewhere between 30 and 50% max of companies that have actually written down a scientific data and process strategy. Client culture many times is toxic. Some of the big companies have gotten a little toxic in their environments, and we need to fix that with the culture. You have to understand IT versus business roles, their wants and their needs, tactical versus strategic. In many companies, there's still an us and them mentality. IT, informatics need to be intercalated in the everyday workings of a medium or large biotech, pharma, et cetera. Materials or chemical companies. It has to be a much more unified approach to things, a much more system approach to things. And then the systems in R&D aren't in unison. So you'll see this when I try to explain this in the next couple slides. But if you look to the right, a listing boat is the result of a bad system and things aren't executing properly and things aren't working together and the boat starts to list. And there's all types of factors that can cause that. But in a good system, you can right that ship and you can stand it up and you can get that boat moving forward in the direction you want it to go in. So sometimes the root cause to your success and failures are due to the inherent structure of your organization and its size. So this is really important. This is really important from the time of startup to when you become a very large company. You have different priorities, you have different maturity levels, etc. But you really need to understand this. If you want to be successful, you have to take that extra time and do the right things at the right times. But you, again, like I said, you can get dramatic results with a culture shift in your company. And I just know this from experience. I probably wouldn't be talking about this if I didn't experience this at a company that I used to work for called Lab Answer. And the CEO of that company was adamant that we would have this very positive culture and everyone would guard it. And we did, and it paid huge dividends. So in the end, like I just explained, you kind of can't fathom it until you experience it and do it. It sounds probably a little occultish or whatever, but it really works. So culture does eat strategy for breakfast, lunch, and dinner. And part of that culture you need to consume is the journey mentality, the data process mentalities, the standards that come with them, adopting standards. There's a new consortium underway to start to drive around that. We have the allotrope consortiums. We have all types of things to drive the standards, but a lot of times these things don't get adopted because they don't particularly fit in at the time an organization tries to use them, or they find excuses why not to use them, etc. But really, you should be adopting these uniform languages wherever possible. And there are companies out there that will help with that. There's SciBite. There's plenty of companies out there that will work with you on that. Technology, it's got to be usable. It has to enable the science, and it has to lead to the automation of many mundane tasks and tasks that should be automated. And then lastly, what's in it for them? You really got to make sure that you're enabling the scientists today. You're not giving them something more to do because they can't handle it. They don't have the time. They don't have the time to even learn some of these things sometimes. So you have to make sure that the tools that you're bringing and the solutions you're bringing are enabling the scientists. And that's what's in it for them. You're not giving them more work to do. You're actually helping them reduce their workload so they can actually do more science, more data science, etc. So that journey mentality, just let's talk about this a little bit because it makes all the difference as you approach new solutions. And like I mentioned before, the world is really starting to get to this in silico first approach to science, where you can take all that data and hopefully it's model quality data, but if it's not, you got to work to get it there. You're going to take all that model quality data and you're going to start driving that in silico first so that you increase your efficiencies, you reduce the amount of time and money you spend getting to that answer faster as a scientist. Sometimes you don't even know where to start. And by being able to model that, use that model quality data, use the machine learning, et cetera, it can help you even know where to start and dramatically reduce your footprint and time to completion. I've had 40% efficiency gains using machine learning. So just remember that. That's a really large efficiency gain. We're on this journey is a big part of the mindset. This journey that you're on, it's about programs, projects, it's about points in the journey, but it's constantly changing. And that's the difficult part about discovery R&D today, is that it's very dynamic. There's always new science coming along. There's new processes, etc. But you really got to put that journey mentality in there. And you also got to know that new technology, brand new ideas really take about 30 years before they become ingrained and to a point where they're extremely usable and part of everyday society. So you just gotta think about those things and be pragmatic. And then getting back to the whole title of the talk, you know, the English word for human shelter is building with a D, not builting. The building's never done if you think about it. You put up a building, but throughout its lifespan, before you rip it down or demolish it, it goes through an infinite amount of changes. And that's the point of why it's called a building and not a builting, because it's never done. But our perception is, oh, that building was just built and it's done and it looks great. But over the years, it's going to change dramatically, interior, exterior, etc. So that's the point of that. If you didn't learn anything today, maybe you learned that one. It's a good conversational piece. All right. So the systems of a building and the overlap to an R&D enabled by IT and informatics. So here's the point that I'm trying to make. There are systems that occur today in R&D that need to function probably a lot better than they are. IT is trying to provide the infrastructure, maybe even some of the virtual capabilities like high performance computing software, the advanced analysis capabilities, security, all those things that kind of come, you know, with a building, with its infrastructure, its, et cetera. But if you get down to the main aspects of like plumbing your data, processes, and instrument, pulling all that plumbing together, there's only a handful. There's a lot of companies in the world that will charge you a lot of money to go and do that. But there's only a handful of smaller companies that are trying to really move the needle, trying to drive standards, trying to take approach. Tetra Science is one of those. There's a couple others out there. And a lot of the vendors like Dotmatics, IDBS, others, they're working together with other companies to try to really solve some of this problem. You know, like the Agilents of the world, Waters, et cetera. They've helped create and drive some of these things, but now it's gotten a little convoluted, and this needs to get more under control from a master plumbing perspective. Imagine the complexity in a skyscraper today when it comes to plumbing, right? You really have to be a master plumber or set of plumbers to do that and do it properly. The same thing is true in an R&D environment with all the instrumentation, all the data, all the processes, and all the different flavors of science that are going on. Another part of this is the communication systems. Now, now we've included voice in that. So you have the at-home Alexas and, the Google and Amazon have worked really hard, but now there's companies like Lab Voice that are bringing that into the professional world as well. So a lot of times our social life or our private life seems to be a little more advanced than the technology in our work life, but the tides are changing on that a little bit. And then the next part is really about the foundation that you build all this on. And one of the points before I get to that I wanted to make, and I actually forgot about, is that there's new buildings in the world that are starting to drive how our R&D brick and mortar could start to do a better job or better approaches, et cetera. Because at the end of the day, if you're going to spend a couple $1 million on a new beach house and a hurricane comes through, you want to make sure it's still standing, or at least a large majority of it is. So being smarter about the modularity and the approaches to this parlays into their R&D world as well. So one of the key aspects that I just want to bring from the building world as well is a lot of this is now done with building standards, a lot of standards to make this more uniform and a much safer and better approach. And that same type mentality should be brought into R&D, where we're adopting more and more standards to drive this forward. So like I was talking about before, from a new molecular entity or a formulation or a material science, whatever flavor and science we're talking about, this is really a very dynamic approach to things, and it's never a very circular thing. There's a lot of failure, probably more than 80% failure compared to success. And as you go from ideation all the way through decisions, there are a lot of choices out there in companies that are going to help you not only manage your data, capture your data, report on your data, analyze your data, et cetera. And again, a lot of those companies are part of this webinar series, Dotmatics, Biovia, IDBS, Sapio Sciences. You just go down the list, and they're out there working really hard to try to make this all come to fruition. But what comes along with this is the ability and the human behavior that has to be brought in around some of the things that I was just discussing, around the standards, around the approaches, the journey mentality, all those things, and critically the change management that goes on throughout all this. So whether it's entity registration, request management, request management is one of these very, very important systems that should be in every major company and should be part of what ties together a lot of your data and processes, etc. But the sample management, your ELNs, your LIMS systems, the IoT, the integration bus that comes into play, like I was talking about briefly, your chromatography data management systems, and finally your scientific data storage and foundation. So getting back, trying to tie together the culture and IT and all that. So the proper organization and architecture really helps future-proof what you're trying to do in a company as an organization, as a big team. The foundation or the footer, you have to dig underground and put in cement or very large stones to build your structure on, right? That's how you have to do it properly so your building doesn't fall down. That's your scientific and business leadership. That's the foundation that you're bringing forward. Your culture is your cornerstone. That's the first stone that's laid that things above the surface are going to be built off of. Your data and your processes are your keystone. They shouldn't be under any stress. It should be fair, like I said before. It should be the piece that ties everything together and allows you to be a data-driven organization. And it's critical because that knowledge pyramid, the higher you get up, when you get up into past knowledge, you get into intelligence. And that just means you're making really good decisions because you're able to tie it all together with the data-driven approach. And then finally, the capstone. The capstone is the technology that sits over all top of all of this. And the capstones can change. You know, they're the ones that are going to wear out first, and you're going to replace them. But they also protect and help drive the rest of the structure here. So I did my best to try to explain this. I've been trying to explain this for years, but this is really, it's this simple. If you can kind of speak about your approaches in R&D with this and making sure you have all these pieces in place, I guarantee you're going to be very successful. So what I kind of described were the 4 pillars that I always talk about: the people or the culture, the data and processes, and technology. And when you take this holistic approach, you drive the organizational change management, you drive system harmony, you get executive sponsorship, which is critical. You have clear communications, scientists to scientists, IT to science. You have the process capture and optimization, the domain experience that you need, the stakeholders, the team is working as a highly functional unit, and then the technology you bring in is that enabling technology that brings it all together. So if we talk about IT in a little bit, a lot of people like Gardner and others would describe IT as bimodal, but actually IT is trimodal. So you have the big corporate IT that provides the security. In some cases, it's going to slow you down, and that's not always a bad thing, but it's not always a good thing either. So you've got this large cruise ship that can do a lot of things, does them in a more enterprise way, keep you entertained a little bit, etc. But actually, the speedboat, a lot of those informatics groups that are embedded, or the embedded IT groups that come around, are the ones that are very agile in getting things done. And as long as they're in tight communication and understanding with the cruise ship, they can help you and help you very well and very efficiently. Then the third part that people seem to gloss over is the stealth vessel, or the groups that are either in the business or business and IT, and they're really pushing the envelope. They really know their science, they really know their processes, and they're actually very technically savvy. And they can either prototype, build things, or bring in the right vendors to do really cool things and move the needle. When you have this in harmony, you're going to have an incredible journey, and you're going to have an incredible experience. Unfortunately, too many times these things are out of harmony. And there's more infighting going on than actually getting together and getting things done. So, you know, assess this in your own organization and see how you can improve that. So, fair data and processes, it's like recycling in your building that we were talking about before. We as humans just throw away so much. It's actually gross. It's disgusting. You know, you should take a field trip to your local dump or landfill, and you'll see what I'm talking about. We could do a much better job as a human species. But the point I'm trying to make here is we do the same thing in R&D. A lot of this data, and I'll show you a slide, is dark data. It's 70% of it's just sitting there, never to be used again, using energy to keep it there, etc. But what we want is that findable, accessible, interoperable, but reusable data environment. And this is like recycling, right? You really should plan on making your data extremely shareable. Now, I'm not telling you to go share your data with whoever, whenever. I'm saying it's in a mode where it's shareable when the timing's right, when the deal's been done, when the permissions have been granted, et cetera, et cetera. And this happens at a time of a pandemic when companies all of a sudden are working together to try to solve this, and they need to share data, and they need to make heads or tails of that data. A critical time, a very humanitarian time. And I wrote this actually, this slide several years ago before this pandemic, but with competitors, governments, and orgs. That's exactly what's going on right now, right? With everyone. But again, it's the security's in place. You just have to lift the security when the time's right. But this is critical. And I can tell you a story where a company was being bought, and they were evaluated at, let's just say, $1 billion. And that wasn't enough. And what we did is help that company extremely improve their data environment. And they actually sold for close to $5 billion 3 years later. So not only from a humanitarian perspective, but a drug discovery perspective, but also from a revenue perspective or a future acquisition or merger perspective. I could tell you stories all day long about companies buying companies and for lots and lots of money and not being able to make heads or tails of all the data that they bought. So why an asset is a thing of value? This is what we were talking about before. And um, data and processes are one of your number one assets besides the people that work in your organization. So it's a highly critical thing. And it leads to that replication and reproducibility, et cetera, and everything that I just talked about. This image is really about somebody can take what's perceived as trash and making something really awesome with it. So as a scientist, you had no idea that the plastic or the bottles that being produced were ever going to be used as a boat. And you could parlay that into a small molecule, a large molecule material where something was discovered or invented for one purpose, but got reuse years later, months later, decades later for something else. And we're seeing this today in drug repurposing around COVID-19. Everybody's trying to repurpose a drug to at least treat all the very sick people out there right now, to reduce the symptoms and get them healthy. So it's not necessary as a scientist what you're doing right at that moment, but it's about the reuse of all that data and material for something maybe even bigger than better than what you're working on. So how would you go about doing this in your organization? And I've talked about this slide in multiple webinars and stuff, but it's really important. There is a cadence to this, and it may not be exactly the same for everybody. You may decide that you got to switch maybe a couple of these around. That's fine, but you really need to understand culture and change management. You need to understand what your scientific data and process strategy is going to look like. If you don't have tools that does functional scientific business process mapping, well, what does that mean? A tool that actually captures your processes and executes the experiments on top of that, so you don't have two separate entities for process maps. But many don't have that. So you're going to have scientific business process mapping. I can't tell you how many people 3 layers up have no idea what's going on in that laboratory. And the truth is, many managers of that laboratory don't understand the details. If you don't understand the details, it gets harder and harder to solve your problems with software technology and solutions, etc. So if you want to buy insurance or prevent failure in your informatics or IT ventures, business process map your labs before you engage in software, because you may end up buying the wrong tool. Understand your data. I can tell you that 80% of legacy data is not worth migrating into a new system. So do your scientific data assessment, and or I'll do it for you. But do that assessment to make sure before you go and spend all that money on moving data around. It's an awesome time to harmonize your processes, optimize your processes. Do your standards adoption, get your ontologies, your taxonomies, your data dictionaries, get that all done. Set yourself up for, and it's all defined in a scientific data strategy, but set yourself up for your master data management as much as possible. Drive your scientific data foundation. What comes along with that is ingestion processes. When you do all that, you will be able to enable high-end advanced analytics. Your data scientists will be very happy, and you will have a fair data and process environment, and you will become extremely efficient. And when I talk about advanced analytics, I'm talking about machine learning, I'm talking about artificial intelligence. All that will start to pay dividends for you as an organization. So what does a scientific data strategy look like? It's really about building a document that people can easily follow, because what happens is if they don't have anything to follow, they start just doing their own thing, which leads to all the disparate data silos and things that are going on in large organizations today. You want to outline your data governance, your integrity. You want to understand the organization and its roles. You want to understand the data lifecycle, how you're going to capture data, how you're going to reuse it, what's high quality data mean, what is high quantity data, like how are you going to reuse that data so that you can protect it. Like as I spoke before, the master data management, and then the infrastructure that comes in with that. It takes overhead to run all this, but it's a much more defined overhead than everybody running around right now in many large organizations, upwards to 80% data wrangling. That is extremely inefficient and a waste of money. And hiring more data scientists to be the Band-Aid is not a good strategy. I talked about the dark or trash data before. It's a reality. It's a reality at almost every company I know. So, and I know a lot of companies are working hard at it, but between 50 and 80% of an organization's data is unused. It's a horrible number. So what is scientific data? It's a lot of money. If you're talking multi-billion-dollar R&D budgets, that's billions of dollars by each major company. And then you combine that with human intuition, which is one of the most valuable assets at a company. And you combine that with the experimentation and the cost of that, as we outlined in the budget, and the cost of the equipment, the cost of the scientists, the cost of the time. You end up with tons and tons of data. And if you properly contextualize it, it's got even more value than if you don't. It's another form of currency. Your materials, your drugs, whatever it is, it's just converted currency. And it has extreme value. Any of those vials down there without any labels on it or anything, no printing on the capsules, whatever, it's worthless. You have no idea what that is. So without the data, it's absolutely worthless. So remember that a lot of effort went into converting that cash into a very highly valuable asset and product. And the data is, again, your top 3 asset in your company. But the processes are critical. And sometimes when people talk about fair, findable, accessible, interoperable, reusable, they don't talk about the process, but the processes are what produce the data. And so a lot of things get screwed up when the process is deviated from and it's not captured properly. So you need to version your processes, you need to integrate, and you need to be very detail oriented for many things. Now, I'm not saying there aren't ad hoc experiments and things like that in research, of course there are. But what I have found too is people will use that as an excuse and say, oh, that's just a one-off. But if you go around the company and you look how many one-offs there are, you start to realize it's more of an excuse than it's not. You really need to capture this for that reproducibility aspect. The transformation needed in R&D today is critical. We're at a critical juncture. And transformation means everybody must change, from the CEO to the new bench hire research scientist. Everybody must change their mentality in order to transform. You need shareable and reproducible scientific data and processes and experimentation. It's industrialized science. This isn't an academic lab or some other loosey-goosey type outfit. This is an industrialized science organization. You need process standards and contextualization. You need data standards and contextualizations. And you will get to this point, and you will have to have this mentality that you're going to do science with a reproducible outcome as a goal. I can tell you that companies around the world are struggling with tech transfer that's half in paper or all in paper. And every time you move from one department to the next to try to get to a marketed product, the type of problems and angst that people have because they can't get it to work costs companies millions and millions of dollars and sets them back. So the sooner organizations transform into more of a digital, um, data first, cloud first type, in silico first type company, the better off they're going to be. So I just wanted to say right now, as you look around the world, the whole COVID-19 pandemic, you're seeing certain organizations that are coming across very organized, very efficient, very effective, and very agile. And then you're seeing others that aren't, including some governments, etc. I won't say any more about that. But the world is observing, and I think the smart people in the world are really observing this, and I think our outcome out of this is we are going to change as as humans in this world after this pandemic because of what's transpiring. But I wanted to thank everybody stepping up and doing the right thing, and I mean people are just donating their lives towards this, which is amazing. But one important part of this, and I wrote a little blog about this back in February, it's time to get your house in order. Right now, while scientists maybe aren't in the lab doing experiments, and they have a little extra time, and I'm not saying that's true for everybody because there are plenty of people that are still working in the labs and stuff, but if your organization could take full advantage of this and get your informatics environment in order, it's going to pay huge dividends for your organization for years to come. And I wanted to thank everybody for your time, and I know there's a bunch of questions.